We're now going to begin the Q&A session. It will go for about 10 to 15 minutes. If I can ask all 9 speakers to come back onto the stage. If you have any questions, there's 2 microphones in the middle of the room here. Just ask that you stand behind the microphone, and then the speakers will be able to answer your question.
First, I thought all those talks were really interesting, so thank you. Unfortunately, I don't remember everybody's name. It would be good to have the names on the board, but I think Dr. Parkasani was one. So I had a question. When you print in your high-frequency sound, what are you printing with inside of mice? What are you printing with?
I've not started that work, but what I'm planning to do is I'm starting something called bioprinting. We're printing biopolymers and extracellular matrix and biopolymers and trying to grow cells with that ECM and print them outside and print inside.
So you would actually infuse the monomer and then print locally, or?
This is, yes. So it's going to be very minimally invasive. This is the idea. And so if we can bring into the material inside wherever and
you distinguished your printing process from the standard methods for 3D printers because you said they used heat or light.
Yeah.
But isn't the ultimate mechanism of the high frequency sound to heat?
Say, at the interaction of the ultrasound with the material, what happened is ultrasonic chemistry that really picks up. This ultrasonic chemistry it's still not a fully understood area, but what's known as this high frequency oscillations creates cavitation at that level, and it creates micro nanobubbles. And micro nanobubbles, cavitation bubbles. And these bubbles implode, implosions, grow implosions, create around 1500 degree Kelvin locally in those parts. It's high pressures are created. So that kind of a high energy, intense field make the phase transformations. If you want to print a material, I think that's where the phase transformation happens. But if you look at the overall heat transfer, that will be less because it's a very, very tiny area. Even though I can think of high temperature, high pressure, but it's very locally happens, right? As a result, the total heat will be less, but so that ultrasonic chemistry is apart from temperature and pressure, it also leads to chemical reactions. I think we more focus on the chemical reactions for those 3D printing.
Can I ask another question of another person? I'm sorry, I don't remember the vaccine person's name. Maybe you can tell me your name since I'm being rude.
Yeah, it's Manish Sadarangani.
Okay. All these names are difficult. Okay, so I have 2 questions for you. The first one is, why is there a correlation between temperature and antibiotic resistance?
Yeah, that's a good question. I don't know is the honest answer. I think this is just right now an association that has been found. The direct causative link or mechanism is not clear and maybe multifactorial. So yeah, I don't know. There may be others in the room who are more expert to speak to that.
And in the second question is, in your Klebsiella, and I should know this, but I don't, and for pneumococcal vaccines, are the responses primarily humoral or cell-mediated?
Yeah, so our lab's expertise and focus is looking at humoral immunity, so antibody, so amount of antibody, function of antibody, and the B-cell responses. So the B-cells, for those who are not familiar, make the antibody. So we collaborate with others to look at the cell-mediated T-cell responses as well. That's not something that we do in our lab. For Klebsiella, it seems to be that the antibody is predominantly what is protecting, but there is also a cell-mediated component to the immune response. And part of the work we're doing, collecting samples from children who've had infections, is to also look at that cell-mediated response.
Yeah, I was going to ask, that's a good segue to my other question, and then I'll sit down so if somebody else can ask. So wouldn't it just be, given the scope and scale of the antibiotic resistance problem that you outlined in your slide, wouldn't it be judicious to collect and make recombinant antibodies against all of these pathogens from immune serum, for example, and just clone the antibodies and make a bunch of antibodies so you can give those instead?
Yeah, so that's a good question. And so I think there's obviously this sort of different approaches using immunotherapeutics, if you like. So there's the approach of vaccination, where you're trying to intervene before the infection, the body mounts the immune response that then subsequently protects, or the what you've described, which is giving antibody either at the time of the infection or in the immediate high risk period. I think the downside of that is that those antibodies are relatively short-lived, so the duration of that would be expected to be 3 to 4 weeks. And so it might be fine if you're expecting to have a very high risk period that is of short duration. But I think if you're wanting a longer response, then
yeah, sure, vaccines are great. I mean,
sure,
preventing it in the long run, but I mean, there's also other potential.
I agree, but I think the application would depend on what the situation is.
Thank you. I'll ask just one question because of other people. My question is and great presentation, by the way. I love the varieties of what is happening, and thank you so much for sharing your work with us. I wanted to ask a question around ethics and the person that is, the researcher that is working on, I think everybody, of course, your research has to do with human beings and all that. So maybe my question would go to everybody around what are you thinking about the ethics of engagement? But particularly for Dr. Olubukola and you and the person that is working on on stigma. I just want to hear more about the ethics of engaging with those communities that you're working with. Thank you. And thank you to everybody.
Yes. In fact, it was tricky to take all the ethics out of my talk when I realized it was only 6 minutes, because when you talk about ethics, you need a little bit of time. Surely the biggest problem, and a very big, I was at another art conference put on, and we had all the AI experts in a room, and the notion is right now that AI seems to be grabbed on by corporate companies, Google and OpenAI and things like that. And even us researchers who are entrusted to make sure that these black boxes are doing the right things. All of Canada, even places like U of T and McGill that have very significant processing power, don't have the ability to even check on what's happening. So I think there's a huge notion, and I'm on a committee even here to do so, to convince our government and other governments that we need to open source these systems more. A lot of my work is to make sure it goes to artists and designers and creatives and the health groups. But right now it's so corporate controlled that the ethics side of it is quite tricky. Also, which is kind of typical with how you should do things, it's co-creation. It's not up to us academics or scientists to figure out what makes sense. It's to work specifically with the communities. And again, because I'm doing work with artists and designers in Canada, we're giving them tools. We're saying, what's wrong? How would you rather do this? And we're doing the same thing in other fields so we can do some level of co-creation. We can't fully do that unless we, unfortunately, just because of you need a building sometimes of these GPUs to get AI to happen, until we get that out of kind of corporate hands and back into kind of government open hands, so everyone will be involved in the ethics side. The last thing I'll just say is we're turning the tide. There are tools that a small group in South Africa trying to push against a system that doesn't seem to have good facts are starting to use AI, to be able to get data that they never would have been able to afford or get in other ways. So as we give these tools to kind of local people, they can kind of push back, especially if there's laws, and show that there's data supporting that wrong has been done to them. So we're starting a little bit to slide the other way now, getting AI in the hands of regular people that they can kind of push back on how they've been oppressed in the past.
I think that was a question for you as well, but unfortunately, we've only got a minute left. Do you want to give it a go and try to answer the question? Okay. And then we'll wrap up.
So I guess certainly in the area that we work in, there are a lot of ethical concerns. We face that a lot in our research, just given the nature of the behavior. There's often a question about an iatrogenic effect. If you talk about these things, will you somehow incite that amongst individuals? The research doesn't really bear that out. In fact, there's research which shows that talking about these things actually helps. Nevertheless, we do have a lot of provisions in place in our work to make sure that people are indeed safe. We make sure they have good quality research-informed resources at all times. We've also done written papers to actually guide the research process, addressing all these ethical issues, and put in place recommendations for even different settings like schools. I realize we're at 13, 12, 11 seconds, so I'm more than happy to address more of this later on in any kind of conversation, so please feel free to reach out.
That was impressive. Perfect timing. Thank you, everyone, for joining us today. Let's give a final round of applause to our speakers. And we encourage you to continue this conversation following the event. If you would like to get in touch with any of these speakers, you can contact us at the RSC and we can connect you. Thank you and have a great afternoon.